Hey everyone, so today's video would be about axioms of rationality, and this video would be in continuation of a previous video where I took three axioms of rationality that were completeness, reflexive and transitive. To give you a short recap, I would be explaining to you the three axioms that I took there. So completeness axiom said that your preferences should be complete, meaning they should be comparable. A person should be able to tell if he prefers the bundle X over Y, or he prefers Y over X, or he is indifferent between the two. The axioms reflexive the reflexive axiom says that if you are given two identical bundles, then you can either be preferring one over the other, or you can be indifferent between the two. And the last transitive axiom said that if you are given y over if you are preferring x over y and you are preferring y over z, then it implies that you are preferring x over z. So these were the three axioms that I took there, and now I would like to take you further and introduce you monotonicity. So what is monotonicity? Monotonicity says that more of a good or both the goods is always preferred. In economics, there is an assumption that all human beings are rationals and they tend to think the best what is best for them. So as rational human beings, we always want to consume more of things that give us satisfaction. So monotonicity says exactly that a person would always like to consume more of a good given his ability. So how do we compare monotonicity given two bundles? This is the process of comparison. When we are comparing the x quantities in both the bundles, then we would be holding the y quantities equal. Or when we are comparing the y quantities in a bundle, then we would be holding the x quantities equal. So I were to explain you with an example, suppose we have two bundles 3 1 and 2 1. You can notice that we are holding the y quantities 1 1 as equal, and we are only comparing the x quantities. So if I compare, we know that 3 is greater than 2, meaning this bundle offers us greater quantities of x, so it would be preferred over 2 1. Now the second example shows that we are holding the x quantities as equal and we are only comparing the y quantities. So we know that 5 is greater than 4, meaning this bundle offers us greater quantities of y, so we would be preferring this over the other. Now the third example is giving both x and y more to us. In this bundle, this x is given as 7 and y is given as 8, whereas in this bundle x is given as 5 and y is given as 3, meaning this bundle is offering the quantities of both the goods more than this bundle. So it's obvious that we will be preferring this one, since monotonicity says more is always preferred. You can just remember monotonicity like more is always preferred. This is the idea of monotonicity. So there is a thing that we need to keep in mind, that monotonicity cannot be compared when quantities of both goods are different in both bundles. What does it mean? It means that suppose I give you two bundles 10 2 and 9 3, and I ask you to rate your preference. Which one would you be preferring? You won't be able to come to a conclusion directly, or you have to think really hard, because the quantities are not equal. Suppose if the quantities of y were equal 3 3 in both the bundles, then you would be able to straight away say that you prefer 10 this bundle over the other. But since the quantities of y are not equal, you have to think, or it may be the case that you are indifferent between the two. So in such cases, we say that monotonicity cannot be compared, so we cannot compare monotonicity here. Similarly, in this example, if I even raise the quantities in both the bundles, then this statement would hold true, because here as well you cannot compare monotonicity. You are given 21 units of x and in bundle 1 and 15 units of x in bundle 2, whereas you are given 10 units of y in bundle 1 and 19 units of y in bundle 2. Since a person always want to consume both the goods in more quantities, he cannot just say that he prefers this or this. He have to think really hard, or he have to make a trade off between the quantities of x and y and choose between the one. So monotonicity, when we want to compare monotonicity, we have to hold at one, either x equal or y equal. So monotonicity cannot be compared here as well. And even if I raise the quantity to many more, suppose that in these example that quantities of x is 100 and y is 150, and in this example there is 1 lakh unit of x and 90,000 units of y. In this example, in these as well, you cannot compare monotonicity, simply because you are not holding one good quantities of one good as constant, and you have to, as a person, he always prefers more of a good than the less, more of both the goods than the less. So he cannot, the monotonicity cannot be compared here as well. So you cannot compare monotonicity here, and you cannot compare monotonicity here. So this was all about monotonicity, and the next I would be explaining to you would be convexity or convex preferences. So convexity or convex preferences, whatever you can call it, suggests that a consumer would always prefer combination of the two goods, and that there would always lie a trade-off between the two goods. Now these two are two separate statements that I have just said, and the first, that the consumer would always prefer a combination of the both goods, can be explained better with averages are preferred over extremes, and that there would always lie a trade-off between the two goods can be explained better with marginal rate of substitution is diminishing. First, I would be explaining to you what is averages are preferred over extremes. Suppose that you have two bundles A and B. In bundle A you have 1 unit of x and 4 units of y. In bundle B you have 4 unit of x and 1 unit of y. And suppose that we are given a utility function, that is u equals x raised to power alpha and y raised to power beta. For simplicity, we are going to assume that alpha and beta are equal to 1. So that makes our utility function u equals xy. Now we are also saying that the utility that we are deriving from the bundles A and B is the same, meaning the consumer is indifferent between the two. When I say that the consumer is indifferent between bundle A and B, what do I mean to say is that A and B lies on the same IC. The bundle A and B are lying on the same IC. This is our IC, as you can see. Bundle A will lie somewhere here, because you can assume that this is where the quantity of x is 1 and quantity of y is 4, and this is where quantity of x is 4 and quantity of y is 1. So bundle B would be lying here. Now from mathematics we also know that average of two numbers is sum of the digits divided by 2. So suppose that the average bundle that we want to find for A and B, we are calling it C. So if we make calculations for our average bundle C, then as I said, we have to sum the x quantities and sum the x quantities and divide it by 2 to get the x quantities for bundle C, and we have to sum the y quantities from A and B and divide it by 2 to get the y quantity of C. This is what I have done here as well. Let us call the x quantity of C be x3, then x1 plus x2 by 2 equals 1 plus 4 divided by 2 equals 5 divided by 2 equals 2.5. This is the x quantity of our average bundle C. Now for the y quantities we will do the similar calculation, and the y quantity we get is the same as 2.5. So our average bundle is ready, and our average bundle is 2.5 for both the quantities of x and y. Now from mathematics again, we know that average of any two numbers always lie between the two numbers. That is, when we join the two numbers with a line, then the average of the two would be lying as a midpoint on the line that is joining the two bundles. This is what I have done here as well. I have joined the bundles A and B, and I have placed the average bundle C right in the middle, because C is the average of the average bundle of the two. It will be lying right in the middle of it. Now to do a utility analysis and to find out which bundle is giving the highest utility, so that we can say that it is most preferred, we are gonna take the three bundles that we have now. The average bundle that we calculated, C, is 2.5 for both quantities of x and y. So to check utility, whenever we have to check utility, we simply take the bundles and plug in the values of x and y into the utility function. The utility function that we had from earlier is x and y, that is a Cobb-Douglas utility function. So let us take the first extreme bundle, since we have found that the C is average bundle of A and B. Then bundle A and B would be extreme bundles. Let us take first the extreme bundle A, which is 1, 4. So when we plug in the values of x and y, we get that the utility that we derive from consuming A is 4. Similarly for B, when we plug in the values of x and y for B, the utility that we are deriving is 4 again. But when we plug in the values from our average bundle C, we get that the utility that we are deriving is 6.25. The average bundle is giving us a higher utility, and higher utility means that the bundle would be lying on a higher indifference curve. This is how things work when we do our utility analysis. When I say that the bundle C would be lying on a higher indifference curve, what do we mean is that, suppose that the IC that we took earlier for A and B is the IC that represents the utility level of 4. Now since we have found out that the bundle C would be lying on a higher IC, that is IC that is providing 6.25 level of utility, we know that the average bundle would be lying on the higher IC. And since higher utility means higher indifference curve, a consumer would always prefer a bundle that is lying on higher IC. Or you can say that there would always be a chance that the consumer would, given his budget, whatever budget income constraint that he will always want to go to a higher IC and achieve a bundle that lies on a higher IC. So we can say that the consumer prefers C over A or B, simply because C is giving him combination of both the goods, and C is giving him higher utility as well. So this satisfies the convex preferences, and it also satisfies the statement that I said earlier, that a consumer would always prefer combination of both the goods, and average C is preferred over the extreme bundles A and B. So the second statement that I said was that there would always lie a trade-off between the two goods, and this can be explained well with the concept of that marginal rate of substitution is diminishing. So first To know about why marginal rate of substitution is diminishing, we first need to know what is marginal rate of substitution. Marginal rate of substitution can be abbreviated as MRSXY, and marginal rate of substitution is also the slope of the indifference curve. So, marginal rate of substitution is the amount of good Y that the consumer is willing to give up to consume additional unit of good X. And to explain why marginal rate of substitution is diminishing, it is because for additional unit of X that the consumer want to consume, his willingness to give up Y would diminish. Now, to explain this concept well in detail with the help of an indifference curve, I would first like to tell you that the delta here means the change, and delta is represented by this, and MRS, meaning marginal rate of substitution, is actually change in Y divided by change in X, meaning change in quantities of Y divided by change in quantities of X. Now suppose we have an indifference curve, and on that indifference curve we have 4 points A, B, C, D, and the consumer, since these points are lying on same indifference curve, the consumer would be indifferent between all 4 points, meaning he derives same level of utility from all 4 points. Now, as the consumer goes from point A to point B, we can say that we can observe that there, for a small change in X, there is a large change in Y. So we can say that the quantities that the consumer is giving up to consume, the quantity that the consumer is giving up of Y to consume more of X is larger when he goes from point A to point B. So when the consumer goes from point B to point C, we can notice that for this change in X, there is a similar change in Y, meaning the consumer is giving up similar amount of quantity of Y to consume additional quantities of X. And as the consumer goes from point C to point D, we can see that there is a large change in X for a small change in Y, meaning consumer here is only giving up a small amount of Y so that he can consume a large additional quantities of X. So the point here to note is that psychologically the consumer is less willing to trade Y when he has less of it, and this is obvious as well. If I am given an offer that you can have more of X, but you have to give up Y, and I already have less of Y, then I would make sure that I get a large quantity of X so that it can make for the lost satisfaction or lost utility that I give up when I give away my already less quantity of Y. So now to explain why MRS is diminishing with the help of these points on the indifference curve, we can notice that since the change in Y was greater than change in X from when the consumer goes from point A to point B, we can say that the ratio here, the ratio of change in Y divided by change in X, is larger when he goes from point A to point B. And when the consumer goes from point B to point C, we notice that the change in Y was similar to the change in X, so the resultant ratio would be 1 here. And as the consumer goes from point C to point D, the change in X was greater here, so the denominator was greater and numerator was lesser. This is the reason why this ratio, when he goes from point C to point D, would come out as a smaller number. So as you can notice that the ratio is continuously decreasing as he moves along the points on the IC. So this is the reason why MRS diminishes as the consumer goes from point A to point D, from point A to B, then B to C, then C to D. So this was all about axioms of rationality. Thank you.